So moving along. So we quantify solution composition by using various forms of concentration. Okay, so how much solute is in our solution. And we do that by using molarity. And molarity is always given with a capital M. And we also use brackets to express molarity. So for example, if I were to write bracket, let's say Na plus bracket, okay, this is shorthand for the molarity of Na plus in an aqueous solution. So we want to start getting used to seeing these brackets in chemistry. These hard brackets mean molarity. Okay, so what's molarity? Molarity is the mole of solute. So how many moles of solute divided by the liters of solution. Okay, so oftentimes we might see the letter N for moles and capital V for volume of solution. Okay, so a lowercase n is often for moles, okay, and a big capital V is often the symbol for liters. So moles per liter equals big capital M. So I'm giving you several different ways. This is common in science where we have several different ways of expressing the same thing. All right. So we can do dimensional analysis or stoichiometry on our definition of molarity. So for example, suppose I take V, the liters of solution, times big capital M, the molarity. What do we get? Well, V is liters of solution, okay? So that's liters. And look, molarity is the same thing as saying mole per liter. So the liter and the liter cancel, and you're just left with moles. And specifically, that's the moles of the solute, okay? So that could be the sodium or the chloride or both, right? Okay, so if we now, on the other hand, take our mole of solute, okay, so that's I'll represent with lowercase n for our moles of solute, divided by our molarity, big capital M, okay? So that's the same thing as saying now mole times, and then look, if we divide by molarity, so we know that molarity is mole over liter. So if we divide by molarity, we flip it. It now becomes liter over mole. And the mole cancel, which just leaves us with liters, right? So up here, right, we got mole, okay? So instead of trying to remember formulas like do I take moles divided by molarity or do I take volume times molarity, just remember your dimensional analysis, okay? So for example, if something is 0.5 molar, so that's the same thing as saying that it's 0.5 moles in 1 liter, okay? So that means the same thing. And so now, in the same way with our dimensional analysis, right, in my process where I go down, up, down, up, down, up, okay? If we can recognize that I can convert, let's say, 0.5 molar into 0.5 moles over liters, now I recognize that I can flip this around just like I do with density in my dimensional analysis problems, okay? And I'll have several examples for you to work on in our discussion, all right? So moving forward.